Alright guys, welcome to lesson 3.3 of Math 0314. We're going to be talking about what's called the addition method. Typically in high school it's called the elimination. Alright, so what are we going to do here? Well, in this method, let me review what we've talked about thus far. So we've talked about two different ways of solving systems of equations. Okay, one way is you could solve it is via graphing. Another way is we could solve it via what's called substitution, where we isolate a variable. A tertiary or third way we can solve it is by literally subtracting the two equations. So how does this work? Well, we're going to look at these two equations here, and we're going to ask ourselves, can we make the coefficient in front of the x's the same or the y's the same? And we can see with the bottom equation right here, it's very easy that if I just multiplied the bottom equation by 4, I would end up getting a 4y here with a negative 4y here. And that's exactly what I want. So let's do that. Let's take it, the bottom equation, let's multiply through by 4, and we'll get, just rewrite the top one as is, but the bottom one's now going to become 16x plus 4y equals 36. Okay. I haven't changed the equation except for amplifying everything by a factor of 4. And the reason why I want this is now I can use the addition method and add the two equations together. So give me 19x, the negative 4y and the 4y subtract out, and I'm left with 19x equals to 38, which is a very easy equation to solve. Divide through by 19, and x is 2. So x is 2. And then from here, I can use whichever equation I want. I can use the top one, I can use the bottom one, or I can use the amplified version of the bottom one and substitute x in. So I like to substitute into this one here because everything is positive initially. So I'm left with 4 times 2 plus y equals 9. And then 4 times 2 is 8, so 8 plus y is 9. I'll subtract out the 8. And y becomes 1. So this tells me that my answer is 2, 1. And that's it. And so again, just like in the previous sections, we can graph it, and we can see here when I graphed it that we get 2, 1, or we can take 2, 1, and we can substitute 2, 1 back into the original equation, right, into both equations, and see if it's true. So here 3 times 2 is 6, 4 times 1 is 4, 6 minus 4 is in fact 2, and here 4 times 2 is 8, 8 plus 1 is 9, so that one is in fact true as well. So, and by the way, I will also encourage you should take these values on a test, whatever your x and y component are, substitute it back into the original equation, and make sure that you do get the correct answer. But if you do have a graphing utility, it's very easy to see that we did in fact get the same result. So, I will say this, most students actually prefer over time elimination over all the other methods, but the truth is you can always use, and even on a test, I don't care what you use, just get the answer right. You can use whatever method you want. I personally tend to use elimination unless it's very easy to isolate y. So, why don't you guys pause the video and try the next one on your own. So I'm going to assume that you've done that. What I'm going to do here is I'm going to multiply through by negative 2 on the bottom, and hopefully you can clearly see why I'm doing that. And that's because it's very easy to get negative 2x. If you have a leading coefficient of 1, that's usually the best bet, unless it's painfully obvious that you can easily multiply through by another value to make your life easier. So, but usually that's just the easy way of doing it. The 2x minus 2x is going to divide out, or subtract out rather, sorry. It's going to give me negative 7y equals 7, so y is going to be negative 1. Just divide through by negative 7, you'll get negative 1. You're going to take this y value, you can plug it back into whatever you want. Again, I'm going to plug it back into the bottom. We're going to have x plus 2 times, now y is negative 1, equals 3, so 2 minus, x minus 2 equals 3, so x is 5, and there's my answer. So 5, negative 1, will become the answer. So hopefully that makes sense. Let's just keep moving on. Next up, we have these two, and this is a little different because the values on the bottom equation are not aligned with the values on the top. So most students get x and y, have something x plus something y equals some constant. You don't actually have to do that. You can rearrange however you want, but it's pretty clear here that if I just add 4y to both sides, I get 3x plus 4y equals 1, and that's going to work very well with this top equation. So now that we have those two, let's just rewrite them together. So 4x plus 5y equals 2, and 3x plus 4y equals 1. Now comes the next part, which is a little more complicated here, which is that we got to get either x or y to match up, but none of these are very clear to see what matches up. And in fact, they're pretty much the same in terms of level of difficulty, so it's not going to be easier to get x or y by itself. I'm just going to go with x because I read left to right. And what I'm going to have to do is I'm going to have to multiply the top equation by 3, and the bottom equation I'm going to multiply by -4. And as I write this out, hopefully you can see why I wanted to multiply through by 3 and -4 for the equations. And the reason why we're doing this is because when I add them together, the x's now will cancel out. I'm essentially finding the LCM of these two, right? And this will leave me with -y equals 2, so y is -2. Now that I know y is -2, I'm going to take that value and plug it back. Since this equation is just right there, we'll use this one, which is technically the bottom one, and substitute back in. I prefer most of the time substituting back into the original equation, because if I made a silly mistake at some point, I'm more likely to catch some sort of issue at the end. Okay, so 3 -2 is going to be my answer. Now I'm not doing this, but you should take 3 -2 and substitute them back into both of these to check to make sure your answers match up. For interest of time and not to drag these videos out any longer, I'm just going to keep moving along. But on a test, you definitely want to do that. So go ahead, take a look at number 4, pause the video, give it a shot, see if you can figure it out on your own. And hopefully you've done that. What we see here on this one is the top equation needs to have the 5x move to the other side. So note on the previous equation, it was the bottom one I had to play with because it didn't align with the top. On this one, it's the top that I'm going to play with. And you don't, again, you could, if you wanted to, I could have moved 3x over. I'm just doing it the traditional way because we're kind of in a traditional setting right now. So we're here. Now on this one, once we write it out in this format, hopefully you see that actually what I really want to do here is just multiply the top by 2, because 2 times 2 is 4, and that'll make these match up. So sometimes you have to multiply both equations, sometimes it's just one. But remember, the goal is to just get either x or y to match up, so that when you add the two equations together, we're just left with x or just y. So here, so x is going to become 1. Once I get this 1, I'm going to take the 1 value, I'm going to substitute it back in. Let me just plug it back in here. So this is going to give me 3 times 1 minus 4y equals 1. So 3 minus 4y is equal to 1. We're going to subtract 3. Negative 4y equals -2, so y is 1/2. 2 over 4, which is 1/2. So 1 comma 1/2 is my answer. Alright, moving right along. On the next one, what we find is that x and, for the top equation, the y's are separated, which is a little interesting. And on the bottom one, we're given decimals. So we're going to do two things here. We're going to put our y's together. I'm going to subtract y from both sides. So I'll get x minus 3y equals 6. And on the bottom equation, I'm actually going to multiply by 100. And so I'm going to get 5y equals 2x minus 10. So let's line those up and see what we can do from there. So x minus 3y equals 6. And, well, with this one, why don't I subtract 2x first? Get negative 2x plus 5y equals negative 10. So let me go ahead and put this a little lower here. I'm going to erase this. So that's my first equation. The second one's going to be negative 2x plus 5y equals negative 10. And now, once again, we're going to look at the 2. We're going to say, hey, how can I get these either x or y to subtract out? If I multiply the top one by 2, I'm going to get 2x minus 6y equals 12. The bottom one's still going to be negative 2x plus 5y equals negative 10. And now when I put them together, I'll get negative y is 2 or y is negative 2. So knowing that y is negative 2, I'll plug back in. Let's see here. Let's plug back into. Now here, I am going to plug back into the new versions just because the new versions, I'm going to plug back in that one, just because the new versions are a little easier to work with via arithmetic. In other words, what would I really do if I was plugging back into the blue? The second one, I would end up moving the y over anyways, and with the second one, if I plug back in there, I would multiply through by 100 to begin with. So might as well use the version that's already been broken down. In any case, we are substituting into here, so we get x plus 6 equals 6, so x is 0. And there we have it. So we have 0 comma negative 2 as my answer. Trucking right along. Go ahead, if you haven't done so already, try to do this one on your own. Going to assume that you've paused the video and done that, and we're going over it together now. So same sort of deal with the top one. I'm going to multiply through by 10. Just write it down here. We're going to get 2x plus 3y equals 15. On the bottom one, I'm going to move the y over here, so I'm going to add y over. So this would be plus y, and this would be plus y. And this is going to end up giving me 5x plus 4y equals 20. Cool beans. We got the two equations set up, and here it's not so clear as to how to make it, how to get x or y to match up. There's nothing that's glaringly sticking out. I'm just going to go ahead and multiply the top one by 5 and the bottom one by negative 2. And this gives me 10x plus 15y equals 15 times 5 is 75. On the bottom one, you get negative 10x minus 8y equals negative 40. So as you work through here, very important, number one, I want you to realize that I multiplied through by 5 just because I read left to right. And I was like, well, x and y basically have the same level of difficulty. So you just used x, but you could have easily just multiplied by 4 and 3 if you wanted to get rid of the y's. It does not matter. The second thing is when you multiply through by the negative, be very careful. It's very easy to make a silly mistake. But once we're here, we just add them together. Obviously the 10x's will cancel out. 15 minus 8 is 7, so 7y. Here we have 35. So y will become 5. Once more, I'm going to take this value of y. I'm going to actually plug it back into the top one here because those numbers are a little smaller. I'm always looking for the easiest way out. And this actually becomes a really nice problem because you get 2x plus 15 equals 15. And we see that we have 15 on both sides, so we can easily subtract 15 from both sides. And we see 2x is 0, which means x must be 0. And there we have it, 0, 5. So, hopefully you're not too stressed out about this and it's making sense. Go ahead and, though this looks strange, I think you guys can figure out what to do here. Pause the video, think about what we've done on the previous ones, and see what you get. I'm going to assume that you've done so. What makes this one look a little harder is because it has fractions, but we've learned already that we multiply by the LCM of 5 and 2. In other words, the number that's going to quickly get rid of 5 and 2 in the denominator. when we distribute this in, 10 divided by 5 is 2, so that will leave me with 2x. 10 divided by 2 is 5, so 5y. And don't forget to go to the back one as well and get 10. Okay. The bottom one is still the same, negative 4x plus 10y equals negative 20. And pause for a second and think about what's the easiest way to go about solving this. Hopefully you said multiply the top by 2, and we get 4x minus 10y equals 20. And on the bottom we have negative 4x plus 10y equals negative 20. So, hopefully you're starting to see something very strange emerging, which is that we're going to get 0 equals 0, which is true. This is very similar to in the previous video when we had the left and the right to match up as well. And what this means is that your lines, this is not necessarily an accurate picture of what your lines look like, but basically you have one line on top of the other, which means they touch at all points, which means the answer again is all solutions. I think I said last time all real numbers. You could have an R symbol, or if you're in interval notation, negative infinity to infinity. So once you get something like 0 equals 0, the answer becomes everything. Everything will work because basically the two equations are the same. If you get I guess the next question, natural question to ask is, what about if you get something like 2 equals 3? Something that's not true. And I'm going to leave that question to you. Think about the previous video. What do you think the answer is? And I hope that you quickly said the answer is going to be no solutions, right? Nothing is going to work because the equations are essentially going to be, and hopefully you can remember from the last video, they're going to become parallel. So, hopefully that's not too bad. Let's flip over to number 8. Go ahead and pause the video, take a shot at it, see what happens. Okay? So, I'm going to assume that you've done so. What people are doing to try to make this problem a little intimidating is they're putting fractions, but we'll just distribute 3. We'll just rewrite both of them, so 3x plus y equals 4 is the top equation. When I distribute, I get 3x plus 3 times 1/3 is 1, right? Just 3 divided by 3, which is 1. So y, 4/3 times 3, the 3 and the 4/3 is going to divide out, and we're going to be left with 4. Notice again here, and I'm not even going to necessarily solve it, the top and the bottom equation are identical, which means they're the same equation, which means the answer has to be all solutions, right? The answer has to be all real numbers, right? They're the same equation. They have to have the same answers, right? The answer is going to be negative infinity to infinity. I feel like I wrote it one other way. Oh, all reals, okay? So that's not too bad. Go ahead, last one, try number 9, see what happens. Pause the video and see what you get. So I'm going to assume that you did so. In this one, everything's all scrambled all over the place. What I'm going to do first, and hopefully this makes sense, I'm going to move 18 over by subtracting it, and then I'm also going to move 6y over by subtracting it. So I'm going to get 10x minus 6y equals negative 18. So essentially I'm switching these positions, which means their signs have to change. The bottom equation is still 5x minus 3y equals 9. And we can see something happening here. What I'm going to easily quickly do is multiply the bottom one by 2, and I get 10x minus 6y equals negative 18. And the bottom one's going to be 10x minus 6y equals 18. Now, be careful here, because it's very easy to follow through with what we did on the past one and say, hey, the answer is everything, right? It's all real numbers, it's all solutions, it's negative infinity to infinity. But the equations are not the same. This one here, the bottom one is negative, the top one's negative and the bottom one is positive. So notice that if I was to multiply the bottom one through by a negative and change the signs, and if I add these together, I would end up getting 0 equals to negative 36, which means this one has no solutions, right? Which means this one is the empty set. Oops. Right? Again, why? Well, if let's go back to when they literally go back to when they were written almost identical, right? So what this means from here and here, we know that because the x and the y values share the same numbers, they're going to end up having the same slope, right? But because the back numbers are different, that means the y-intercept is different. So what I'm drawing here is not necessarily the exact picture of what's occurring here. But what we're going to see is just like in the previous video when we talked about substitution and no solution. If the slopes are different, are the same, but the y-intercepts are different, right? Doesn't matter what my picture looks like. If that's the condition, then the lines will never touch, right? And so there we have it. So I hope that makes sense. The last couple conditions are more conceptual at the end of the day, and I hope that you begin to, though we've learned multiple ways, it's very easy for people to gravitate towards one method while forgetting about the rest. But what we can see, especially particularly in this explanation, is that if your mind is capable of thinking about multiple ways of solving a problem, then on an exam, you can, if one method isn't seeming to work, you can always jump to another. And this actually goes back to Descartes, who really was the first to found that we can do math algebraically or we can do it graphically, and they give us the same result. And in that spirit, I hope that you guys will try, as you work through this section, try to use multiple methods. Try to think about it in multiple perspectives. On difficult problems, you may need to use more than one method in order to understand what you're doing or what's going on. In any case, thanks for listening, guys, and we're done with Chapter 3. On to the next lesson.